All right, so we are on now test 1, section 4. Let's go ahead and take a look at number 1. Number 1 tells us that John, he runs at different speeds as part of his training program. So the graph, and I have like a little quick version of it here, but the graph shows his target heart rate at different times during his workout. So in which interval is the target heart rate strictly increasing and then strictly decreasing? So I want to know when I look here that it's doing one of two things. It is just going up and just going down. Now this is a type of rate of change or a slope question. When it's going up, it needs to be, obviously as you go to the right, you need to be rising. So, and then we want to strictly be going down. Now that word strictly means that this interval right here is ruled out because it goes up, then it doesn't change, the rate of change stays constant, then it goes down. But if you look right here, in this little section, it only goes up, so it's strictly going up, and then it's strictly going down. So what we want to do is we want to see when that occurs. So you look at your chart, that's going to occur, it looks between 40 and 60, because that's 40 where it starts, 60 where it ends. So that's going to be our answer. That's going to be between 40 and 60 minutes. So that's going to be answer choice B. So that's number 1. Number 2 says if y equals kx, so this is going to actually be a direct variation equation. So y is equal to k times x. And then what they're saying is y is 24 when x is 6. So what I'm just going to do, I'm going to take this equation and I'm going to call y 24 when x is 6. Now this k here, all it is, it's a constant. It's representative of a rate of change as well. So we're going to solve for this, and once we found it, we found it. It stays in our equation. The x and y, those are variables, so they change over time. So again, those will be different as we move through this problem, but k will not. So I'm going to divide both sides by 6. So my constant in this equation is going to be 24 divided by 6, which is 4. So now my equation, when I look at it, it's going to be y equals 4x. So I'm going to take this and plug in, it looks like x is 5. They said, what is the value of y when x is 5? So I'm going to go y equals 4 times 5. So y is going to equal 20. So 20 in this case is going to be answer choice C. So that's going to be number 2. So keep going here. We're now moving on to number 3. And this one is giving us this picture. And it says in the figure above, lines L and M are parallel. And again, you can kind of tell they're parallel. If you want to label that, go right ahead. You don't need to, though. But they're saying that they're parallel, and S and T are also parallel. So if the measure of angle 1 is 35 degrees, so I'm going to go ahead up here and label this 35 degrees. What is the measure of angle 2? So when you're dealing with parallel lines and transversals, what you have is you have big angles and you have small angles. That's really one way to look at it, to try to simplify things. So as you look at this picture, since all these lines are parallel, S and T are parallel as well, any angle that I get here and here is going to be the same as I get in these sections. So long story short, I have a small angle that I'm starting with. I need to find a big angle. Well, what you need to know about big angles and small angles, big plus small is equal to 180. They're supplementary. So I'm going to just come over here and I'm going to find this angle right here because these two angles are going to be congruent. So to find that angle, I'll kind of use this formula here. I'm going to go 180 and I'm going to subtract my small angle. So in this case, my small angle is 35 degrees. So that's going to be 145 degrees. That's going to be my big angle. So when you find that, and that's angle 2, that's 145, because that's also this angle. Those are the same. So angle 2 is 145, which is answer choice D. So that's going to be number 3. So next up, we have number 4. I'll give you the statement that said 16 plus 4x is. Now, is means equal, so I'm going to just go ahead and start writing this. I'm going to say 16 plus 4x is, which means equals, 10 more than, and more than is going to be plus. I'm going to go 10 plus 14. So it's 10 more than 14. So this is my equation. And they say, what is the value of 8x? So when you solve this, you're going to probably solve for x, but we don't want x, we want 8x. So we'll get to that in just a second. But first off, let's go ahead and start simplifying. So I'm going to add 10 and 14. So that's going to give me 24. And I'm just going to keep solving. So I'm going to subtract 16 from both sides. So now you end up with 4x equals 24 minus 16. So that's going to be, in this case, 8. And now you have the choice of either solving for x and then multiplying it by 8, or you can do a little bit of math here where you can just say, well, I want 8x. So I'm going to take this and I'm going to multiply it by 2. So that's going to give me 8x equals 16. And remember, I'm looking for 8x. So in this case, that's 16. That's going to equal C. So that's going to be number 4. Next up, we have number 5. So number 5, let me get there first. Number 5, all it is just asking for what set of data represents a strong negative correlation. So there's two things that make something strong and negative. So I'm going to just do a quick sketch of the graph. Now, negative or strong, if you just want a quick synopsis here, means that they're really tightly bunched together. All the data doesn't really vary. Negative, that means that your data is going to be going down. So we're looking for the data that is close together and is decreasing. So when you look at your data, A is negative, but it's not strong. B it looks like it's going up a little bit, but it is stronger. C is positive and strong, but D is negative and strong. You'll see the data kind of follows. It's not perfect compared to the graph. I'm just kind of showing you. It's close together and the data is heading down. So number 5 is going to be D. So that's going to be, again, number 5. Next up, number 6 is going to be a conversion problem, and I know that because they're giving me already some conversions. So when I do conversions, I like to mostly do these with conversion factors. So in this problem, they're saying a hospital stores one type of medicine in 2 decagram containers. So I have 2 decagrams right now. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? So what I'm going to do is I'm going to take 2 decagrams, and I want to convert that to milligrams. I want to see how many milligrams I have. So I want to do some conversions, and I have these conversion factors that are going to help me do that. So what you do is you take the 2 decagrams, I'll just go ahead and put it over 1. I'm going to multiply it by our conversion factors. Conversion factors basically 2 things that are equal to each other written as a ratio. Now the first thing I want to do is I'm going to go from decagrams to grams, and then I'm going to go from grams to milligrams. So I'm going to do 2 different conversions, one at a time. So the first one, I'm going to try, when I do this, write it so that the decagrams are on bottom. I'll get that fixed there. And so it's going to be 1, sorry. So when I do this and I put the decagrams on bottom, those will cancel out, and you're going to be now in terms of grams. And I need to go one more here. I want to take this conversion factor and put it in here so that the grams now cancel out. If I do that, I'll be in terms of milligrams. So I'm going to go ahead and put the 1,000 milligrams. Those are going to go on top. And then on bottom, I'm going to go ahead and put 1 gram. So now you're going to see that the grams cancel, and the only unit left is milligrams. So we have 2 times 10 times 10,000 on top. So you'll see it's 2 times 10 times 10,000, and it's just going to be milligrams. So you multiply those all out, you're going to get 20,000, which in this case is going to be D. So 20,000 milligrams, which again is D. So that's going to be number 6, using conversion factors. Moving on, number 7. Number 7 is giving us a chart here, and they're telling us that this chart represents the number of rooftops of solar panel installations in 5 cities. So we have cities A through E, those are your 5 cities. And the total number of installations is 27,500. So again, up here I know the total is 27,500. So that's my grand total. So what is an appropriate label for the vertical axes? So you'll see that the vertical axes, they can be labeled either in tens, hundreds, thousands, or tens of thousands. So if you take a look at all this data, you'll see to get to that total, what you would do is what we're going to try to do. I'm going to add all these numbers up. So I'm going to take the 9. This one looks like it was about at 5. This one here is about at 6. Then here I'm at 4, it looks like. And next up, this is about 3.5. So what you'd want to do is add all those up and see what you get, because that's your total. Let's see what the chart gives me as a total and try to compare them and see how we can get those converted. So this would be 11 plus 9 is 20. This 20 plus 4 plus 3 is 27.5. So this gives us 27.5. So the chart adds up to 27.5, but it should be 27,500. So this is going to be represented in thousands, because it's 27.5 thousands. So the one that has it in thousands is going to be C. So this is answer choice C. That should be labeled in thousands of roofs, because it's going to give me 27.5 roofs, but I have to get it in the right unit. So that's going to be number 7. And then number 8, they said for what value of n is n minus 1 plus 1 equal to 0. So this one actually has a very quick solution. If you're going to solve this, all you would need to do is move this 1 over to the other side. So I have the absolute value of n minus 1 equals negative 1. Now an absolute value is always going to give you a positive answer. Well, that's not going to happen here. So you're kind of like, well, how would I solve this? Well, you can't, and you'll notice there's no such value of n as d, so I would just say it's no solution. And no solution, in this case, is answer choice D. So you're going to pick that for number 8.